All right, hey guys, it's Miss Leslie and Miss Marker. We are here day 21. Holy cow. This week should be a pretty nice week for you guys. It's relatively optional Monday through Thursday if you have been feeling pretty good about the material because it's just a review week. So today we're going to review sequences. Tomorrow we're going to do series. Wednesday we're going to do binomial theorem. And then on Thursday we're going to do more permutations and combinations. So it's really just a big week of review because on Friday your checkpoint is going to be stuff covering all of the weeks that we've done. So it's kind of like a test checkpoint to see how good you guys are kind of doing. So it's still only going to be 10 questions, but it is going to be, questions from like the whole kind of unit that we've done. All right. So today the notes are going to be really quick. It's just going to be like recap of like the main points that we covered for each day. And then the homework is just going to be review questions. So I think that's it. Hopefully it'll be a good week for you guys. Hopefully this checkpoint will be pretty good. I know you guys have, overall we've been doing really well in our checkpoint. So hopefully this one is no different. Ms. Markert, I will pass it to you.
Cool. So today we're just reviewing the stuff we went over in week 1. Each day this week, there will be a video on Thursday. I know we haven't done a video on Thursday in a couple weeks, but each day this week, I'm going to just kind of hit the highlights and hit the things that I think you guys are going to need. I'm kind of going through and just picking out like the main points of each one so that you guys can know kind of where you need to be and what you need to be able to do. And then your homework is relatively short. Some of them are a little bit longer than you've been seeing. But again, they're just reviews. So, whatever you guys want to do, whatever you feel like you need to review. Okay, so today we're going to talk about sequences. And again, this is just the Cliff Notes version. All the other notes are in the OneNote. So remember, a sequence is just an ordered progression of numbers. There we go. An ordered progression of numbers. And then we kind of jumped into arithmetic and geometric sequences, which we'll talk about in a second. But remember that a sequence is just an ordered progression of numbers. I think I used the Fibonacci sequence as an example for this. So yeah. Okay, so then the next thing we talked about were limits. Remember that the notation for a limit is just LIM and then X or N, whatever variable, as it approaches infinity, and then you have stuff in front. And remember that the limit is equal to the value or term that a sequence approaches as it goes to infinity. And I know that's not the first time we've talked about that this year, but these are things that people seem to kind of struggle with still. So we're just kind of reviewing really quick. Okay, so converging. So when a sequence converges, that means that the limit exists and it converges to a unique value. So it approaches a unique value. So if you think about your log function, remember it approaches 0 because it kind of goes like this, right? So it approaches 0 as it goes to infinity, which means that your limit exists and it approaches 0. As an example. Unique value, and it is, I can't spell today, sorry guys. Okay, and then a diverging sequence means that your limit does not exist, and that means that it's either not approaching a unique value or it's just approaching infinity, and it does not exist. So does not exist, and remember that's our shorthand You just write DNE because who wants to write out does not exist. That's just a lot of work. And mathematicians are lazy. Okay, so the next thing we talked about with limits was Bubblebottom eats DC. And this is really good when you have those rational limits. If you don't have a rational limit, you can kind of just figure it out, kind of how the sequence goes, or you can graph it, or whatever you feels right to you. So remember, for Bobo, we have the limit as x approaches infinity is equal to 0, so it converges to 0. And that one's bigger on bottom, approaches 0, right? Yeah, okay. I know what they all are, anyways. And then for bigger on top, we have none, so the limit as x approaches infinity does not exist. And then when our exponents are the same, we divide coefficients. So eats DC, we have the limit as x approaches infinity. You divide the coefficients, and that's what your limit is equal to. And I think that was it for. Cool. Okay, so the next thing we're going to talk about really quick is just the arithmetic and geometric sequences. I'm only going to review the explicit equation because it's the one that you guys are going to use most often, because remember, the recursive equation, you have to have the previous term in order to use it, and most of the time you don't know the previous term, and so it's a little bit annoying to use because of that. So, and it's not something you ever really need to know on a test. So we are just going to do the explicit equations today. If you want to review the recursive equation for whatever reason, feel free, but you're not going to need to really know it. So for an arithmetic sequence, remember that for this one, we're just adding the same number repeatedly. And that number is known as the common difference and denoted as D. Your explicit equation for this one is an equals a1 plus d n minus 1. And remember, for each explicit equation for arithmetic sequence, for geometric sequence, remember that an is the term that you want. A1 is the first term. And then n minus 1 / just n minus 1 is your previous term. And it's really important to keep all of those straight. So that you know what you're trying to find, you know what the question's asking, and you know where you need to put things into the equation. So just remember that. I know we talked about it that week, but just as a reminder, those are all really important to keep straight, especially because tomorrow we're adding in the partial sums, and then you have those. So have those down. Okay. And then for a geometric sequence, we have consecutive, sure, I'll fix spelling later, that have a common ratio, and that is R. And then for our explicit equation, we have an equals a1 times r n minus 1. And again, an is the term you want, a1 is the first term, and then n minus 1 is your previous term. And it stopped updating. That's cool. It's thinking. I promise it's written there. There we go. Okay. The other thing we need to know about geometric sequences is to find the common ratio if you're stuck is you can divide the second term by the first term. So you can just divide the second term by the first term. And if it needs to be simplified or reduced or whatever, do that, because it'll just help you in the long run. Yeah, I think that is about it for today. Your homework for tonight is 11 questions. I gave you an arithmetic sequence, I gave you a geometric sequence, I gave you a couple limits to go through, and I gave you another geometric sequence. Yeah, it's nothing that you guys shouldn't be familiar with. It looks very similar to your homework for this week, week 1, whatever. Some of them I took off of the test review that you would have gotten, so none of this should be hard for you guys to do. Yep, I think that's it.
Awesome. We are also, along with the homework, we're also going to put the checkpoint from that week up as well. So if you want to go back and rework some of the checkpoint problems, because it's going to be similar to your checkpoint you're going to see on Friday, feel free. It is up there for you guys to go look at and practice if you want to. And I will make sure that the answers are also on there, so you can practice your checkpoint questions again. Plus you have these to practice. So technically you have like 20 questions you could possibly do each day to get ready for Friday's checkpoint. But yeah, that is it for today.
Yep.
Guys, we will see you back tomorrow for a review on series. Bye.